Good morning, good afternoon, or good evening, and welcome to Module 2, Unit 2, Lesson 7 for Algebra 7. We're going to look at even and odd polynomial functions. Alright, so our open exercise here, take a moment. I want you to sketch like it says here, f of x equals x squared on this graph. Set up your things to look like my parameters a little bit, spread out that x-axis, and we're going to compact up here and get a lot more and higher values for the y. Then I also would like you to see what happens with x to the fourth power. So punch that in your calculator net, or if you're doing it on the computer, get your either way your graphing calculator. And then finally, what do you think happens with the x to the sixth? And we talked about this back in Algebra 1, but I want you to do it and try to create it. We're going to take a look at that piece. So pause the video and do that, and then come on back. Alright, so when we do the first one here, we know with x squared, I get a point at 0. I get a point at 1, 1, way down here, and that should be even lower, 1, 1. 2 when I squared, I get 4, so it's still pretty low over here. And so basically, we get this type of a graph. Okay, we know it's a quadratic. Start shooting off like that. And so that's our f of x. The first one we plugged in, which is x squared. Okay? Then when we move on to g of x, it's x to the fourth. I'm still kind of going through the same points here, these first three. But then when I go and I do 2 times 2 times 2 times 2, I'm already up to 16 or so. So I'm up here about on each side. And so I get a little bit of a different shoot off here. And so it's the same piece, but now g of x, little narrower on the bowl, okay? So it opens up. We'll talk about that in a second. And then finally, when you did h of x, same thing. No matter what, when I do 1 to the 6th power, 1 to whatever power, it's always 1s. But then at 2, we start shooting off. We shoot off massively. A lot quicker and even faster than even g of x. So that's what h of x looks like. So things that we want to talk about here are, we're going to talk about the fact that in a moment on infinity pieces we'll talk about, but the bottom line is the bigger the exponent, okay, up here, the bigger we get, the faster it shoots off. And so our parabola, or our quadratic, which actually shifts in even powers here, shoots off faster. You get the same thing down below. It actually flattens out a little bit more down here, which we can look at it in class on the graphing calculator, but it shoots off faster. So that's one of the things you want to know. It gets steeper quicker. Okay, so the bigger you write a little comma down here, bigger the exponent. Okay, on an even here, this is an even polynomial, and the reason for that is we are looking at values of x squared, x to the fourth, and x to the sixth. And so we get this shape, and it shoots off faster the bigger the exponent, okay? So we'll talk more about that in class 2, but I want you to get introduced to that. Okay, on this piece here on example 1, they're talking about a sketch of x cubed and then others. I just want to talk about end behavior here is what I want to talk about. So what happens? Well, as we get bigger with the x here, okay, we've got an up-down pattern. That's a whole other thing we're going to talk about later. But what happens is x goes towards infinity. As I get bigger and bigger, what happens to the y? Well, the y goes towards infinity. It's going off forever this way. Okay, we talked about that. And we're going to talk about that as far as limits. There's a little pre-calc coming down into you here into this course. So as we approach infinity, for our x value, our domain, the function f of x also approaches infinity. And on this value here, as we go towards negative infinity for our x value, the function f of x goes towards negative infinity forever and ever that way. Okay? So that's a little bit of an end behavior we want to start talking about when we're looking at this thing. And we're going to talk about that with other pieces too. So just getting that into your head for the moment. Alright, so we just did an even polynomial. So I got even degree up here. And let's take a look what happens every time on an even degree. As I go with my x gets bigger and bigger, going towards infinity, what's it doing? Well, the f of x, the function is going towards positive infinity. It's going up. So that's exactly what this states here. On the other side, as I approach negative infinity, it's not like the polynomial I just told you in the degree. This thing goes towards positive infinity also. So in an even degree polynomial, both functions, no matter what, either way you're going towards infinity on the x, the domain, the input, the output, the range is going to go towards infinity. The only thing that changes here is what happens here. Well, I put a little negative sign out in front, and if you remember from 9th grade, that flips the quadratic, flips it upside down, so it flips the polynomial. So as I go towards infinity, I actually go towards negative infinity for the function. As my domain goes towards negative infinity, my function also goes towards negative infinity. So this negative right there, okay, that's what you want to watch out for, causes both to go towards negative infinity because it flips it upside down. So remember, flips upside, so it flips upside down. The negative causes it to flip. So negative causes to flip. Okay? All right, now let's take a look at an odd polynomial function. All right, so let's look at an odd function now, and we're going to take a look at f of x equals x cubed. And of course, if I put in 0 times 0 times 0, we're still there. I want you to pause this video for a moment again, and let's go do the 3 video and see how you do on your graphing, and graph the f of x equals x cubed, g of x equals x to the 5th power, and then the h of x equals x to the 7th power. So pause the video. I'm going to do it as well, and we'll come back and compare graphs. Alright, so you should have a graph something that looks like mine here. Once again, when we're taking a look at this thing, pattern's still the same. You got zeros here, -1 to 1. Those all turn out to be the same area. General thing flattens out a little bit in there. It actually changes a little bit and flattens out more than what I've got. And we'll talk about that again in class where I can show it better. But after that, when you do 2 to the 3rd power, you're up here at 8. When you do 2 to the 5th power, you're up to 32, and then you're shooting off even higher. So the same thing happens, just like the even function on this side. There's that half a parabola, shooting off faster and faster as we get to the bigger exponents. However, on the negative side, what happens? It flips. It actually turns and goes the other direction. So we got like a -8 here and shooting off, and going further and further down and shooting off faster and faster, so getting steeper quicker. So the same type of thing happens, but obviously on the odd function, we reverse course and go in the other direction. So you're going to see that as the pattern that we're going to talk about. So, odd degree we're talking about here. As I said, as x goes towards infinity, your function goes towards positive infinity. That's what happens. But as x goes towards negative infinity, the function goes towards negative infinity. So different from that of the even. And if I do a negative x squared here, or negative x cubed on an odd, look what happens to the whole thing. Compare this graph to this one. What happened? The whole graph, once again, flips. So you'll want to make sure you make a note of that. Negative, once again, flips it. But it's not the same as the even function where it flips upside down. It flips in reverse. So your piece that was going up this way now goes up to the left, and this piece that's going down here flips over here. So it flips the whole thing over what I would call the y-axis. So now as you go towards infinity, the function goes towards negative infinity. And as I go left on the domain towards negative infinity, the function actually goes towards infinity. So just make note of that. That's the pattern we have here for an odd function. Alright, so to sum it up, I'll see you in class tomorrow. You now know what an even and odd function looks like, and we've got those patterns with the polynomials. Once again, it goes by the degree of it. So if you have an exponent of 2, 4, 6, 8, that type thing, you know it looks kind of like a parabola. Well, -1 flips it upside down. And if it's an odd, you're going to get this type of a pattern like we have right here, going like that and flipping the opposite way. The negative flips it in reverse style. Okay? See you in class.